Start. What would happen? First, what's your parent function? And you could shout out. I don't care. Okay, Liam. Go ahead. Y equals x squared, which is what type of function? Quadratic. Awesome. What direction is this moving in? Right 2. Excellent. Okay, so again, inside brackets, parentheses, okay, under the, God bless you, under the square root, anything attached to the x, you're moving either left or right, okay? What is happening? We'll do this one first. What's the parent function? Absolute value of x, okay, our absolute value function. What transformations are happening? Excellent. Left 3, down 4. So remember, again, inside is your x value. It's the opposite of what you see, okay? Outside is the same sign, okay, saying it's up or down, all right? What's happening here? What function is it first? Square root of x, okay, y equals square root of x. Transformations. Assad? Good. Vertical stretch by 2 and up 6. Excellent. The vertical stretch is in the front. What does that affect, though? If you have a vertical stretch, what values does it change? Think way back to the beginning of the year. The y values, excellent. You're multiplying your y values by this first, then moving it up 6. All right. We have our random function here, okay? I need a few different people that have not spoken yet to tell me transformations. What's happening? What's one? Caitlin. Good. Vertical compression or shrink. We have heard that too. By 1/2. Excellent. What's another? Louise. The negative is the reflection. Good. M. Left 2. Excellent. And last one, Braden. And then down 10. Excellent, you guys. Okay. So that's a little recall of what we've seen back in September, October. Okay. Long way away. However, you guys haven't missed a beat. All right. We've seen this again in polynomials as well. And again, exponentials. Okay. We will eventually get to transformations, but first we have to know what these graphs look like. All right. So one thing about the exponential function, okay, it will be, and you might have seen this on the Delta Math for those of you that completed it, y equals ab to the x, or even b to the x, or something similar to that. The a is the initial amount, and b is your growth or decay factor, which we'll see more so when we get to word problems, but you will be asked to identify if an equation is growth or decay. If it's growth or decay, it depends on this b value, okay? It depends on this b value, right? Some terminology that we're familiar with, domain and range. That's how we describe graphs, okay? What's next is going to be something called an asymptote, okay? An asymptote is like a boundary, okay? You get very, very close to it, but never cross it. Think of like an electrical fence for pets, right? Or dogs, actually. If you have an electrical fence, if they cross it, what happens? They get shocked, right? So they get very, very close to it, just never want to cross it, right? That's the same thing. Same with a boundary. That's what the asymptote is. And you always describe an asymptote as an equation. So typically our parent functions, meaning no movement, will have an asymptote of y equals 0. Okay? So what that looks like is if you look at the bottom of your page, okay, these are what exponential functions look like. which on the delta math, they just labeled them f of x, okay? These are exponential growth. As you look at it, left to right, it's increasing for growth functions. And the key difference is your b value is greater than 1. So I'll give you an example. Y equals 4 to the x would be an example of an exponential growth function, okay? Exponential growth function has a b value, and the b value is always attached to the x, means it's growing, okay? We will use table of values to start in terms of graphing these functions. You will see the key components at -1, 0, and 1. So what would be our y-intercept here? That's another piece we should know. Danielle? No, it's okay. Yeah, okay. It's okay. But we'll get to that in a minute for your point there. Your y-intercept is 0, 1, okay? Is 0, 1. So for example, if I substitute 0 in for x, we get 4 to the 0. What does that mean? 1, right? Anything to the 0 power. When we get to word problems, when you input that 0, that's going to be your starting value, okay, of your y-intercept. Okay, your y-intercept will pretty much be your starting point, okay, for exponential growth functions. Now, for this function, the horizontal asymptote, the boundary line is y equals 0, and you denote it with a dashed line, okay? But it has to be written as an equation. Y equals 0 is your horizontal asymptote. Why wouldn't it be x equals 0? Liam? Okay, okay. Yeah, Jack. Excellent. So if it was x equals 0, it would be a vertical line. But if you notice, if I do a vertical line here, I still have my graph going through it. So that's why it's a horizontal asymptote of y equals, okay? If you look at the second function, okay, this is exponential decay. As you look at it left to right, it's decreasing, and that's how we always read graphs, left to right. So an example of a decay function would be 1/4 to the x. Because to represent a decay function, the b value has to be between 0 and 1. Okay? All right. And we still have the same for this equation. Since there's no movement, our y-intercept is still the same, and our horizontal asymptote is still the same. Okay? So those are the two graphs we will be working with. Okay? Obviously, we're going to start off with just our basic parent functions, and then we move into transformations. But they have not changed from what we're used to. Okay? If you look above, it's identifying if the graph is growth or decay, remembering what we just went through. So looking at number 1, what is our b value? Danielle? This is our b value, 1.15. Is that greater than 1 or in between 0 and 1? Liam? It's greater than 1. So since it's greater than 1, do we have growth or decay? Growth. Good. Now, to find our y-intercept, anytime we need to find our y-intercept, we substitute 0 in for what? X. So 1.15 to the 0 is what? 1. What are we left with? 8,000, which is your A value that you set. Okay, so your y-intercept is 0, 8,000. Now, if there's transformations, it could change, obviously. Now, if we look at number 2, what's our B value? Do you know? So our B value is 0.75. Is that B value greater than 1 or in between 0 and 1? Paris? In between 0 and 1, therefore it's decay. Okay. What is our y-intercept? Assad? 0, 20. Good. Excellent. For number 3, what do we have? CC. It is decay. Excellent. Because 1/2 is between 0 and 1. What is our y-intercept? Addison? Good. Our y-intercept is 0, 15. Excellent. All right, number 4. Genevieve. Growth, y. Good. 5/2 is greater than 1. Excellent. What is our y-intercept? Sabrine? 0, 6. Excellent. All right. How many of you guys got both of those? Good, as you should. Nice. All right, let's get into graphing these. Okay. We're going to start with y equals 2 to the x. Since it's a new graph to us, we're going to start with a table of values. And I included 2 more points there so you could see the full graph, okay, and get some exponent practice. All right, so we have 2 to the x and our table of values, -2 to 2. Okay, so if I substitute in my x values, I have 2 to the -2nd, which would be what? Esteban? 1/4. Excellent. Okay, how about 2 to the -1st? Assad? 1/2. 2 to the 0? Liam? Good. 2 to the 1st? Go ahead. 2 to the 1st is 2. 2 squared? 4. So we're going to go ahead and graph those. Okay. Obviously, for the fractions, do the best you can. Okay. So -2, 1/4, -1, 1/2. Okay. And remember, this is what the graph looks like. Okay. It gets very, very close to 0. It just never crosses for right now. Okay. So what would be the domain of this function? Louise? Excellent. Okay. Any ideas for the range? Danielle? Why? Perfect. So that's the key component right there. Okay. Typically we would look at this and put a bracket, but it's getting very, very close to 0. We can't pinpoint it, right? It's getting very, very small, very, very close to 0. So ultimately, we have our parentheses 0 to infinity because we take that 0 from our horizontal asymptote, which would be what? Where's our boundary line? Yeah. Y equals 0. Excellent. So our boundary line, our horizontal asymptote, should mirror, or match, I should say, our range. What is our y-intercept? Esteban? Excellent. Good. Okay. So if we needed to, before we get into transformations, this would be considered a parent function, just like absolute value, just like quadratics, just like square roots, just like x cubed. Those are parent functions. Exponentials, it's either 2 to the x, 3 to the x, 4 to the x, 1/2 to the x. Those are parent functions. You will not see 1 to the x, okay? You will see 2 or higher or fractions, okay? So now, if we're using this as our parent function, how would the graph change if I had 2 to the x plus 3? Esteban? Careful, careful. Sawyer? Why? Excellent. So our parent function would still be 2 to the x. So we would use the same table of values here, okay? But since our exponent has the x plus 3, it's attached to that x. So x plus 3 means we are moving this whole graph to the left 3. So what is changing? What values are changing? Yeah, Jackson. The x values. So -2 will now become what? -5. -5 and 1/4. Okay. -1 will now become what? -4 and 1/2. Good. Okay. 0 is now what? -3, 1. Good. And we have -2, 2. -1, 4. Okay. So since we moved left 3, x values change. Okay. So looking at domain range, horizontal asymptote, and y-intercept, what's the same? What's one thing that's the same? Nolan, which would be what? Good. What would our range be? Danielle? 0, infinity with parentheses. Good. What would be our horizontal asymptote? Go ahead, Nolan. Y equals 0. So since we only moved left 3, domain range horizontal asymptote is the same as our parent function. Okay. How can we figure out the y-intercept though? Liam. Okay. Okay. Yeah, Luis. Plug 0 in for x. Good. So if we take our function, we have 0 plus 3. 2 cubed is what? 8. So our y-intercept is 0, 8. Okay. Which you will have to find if it asks for it. Okay. All right. Are we good? All right. Let's move on. What type of function will this be? It would be a decay function. All right. We're going to do the same. Table of values. All right. We have 1/2 to the -2nd. What would that end up being? Give you guys a minute to figure it out. Nolan? 4. Excellent. 1/2 to the -1st. Brayden? 2. 1/2 to the 0. 1/2 to the 1st. How about 1/2 squared? Yep. Okay, so we're gonna go ahead and graph those. 2, 4. All right. What is my domain? Addison? What is my range? Cyan? Careful. Careful, careful. What's your smallest y value you have here? Negative infinity would be down here. Zero infinity. It would be that way, and I'm glad you brought that up. You're going to see that in the next page when it changes. Right? What's my asymptote? Addison? Y equals 0 and your y-intercept. Rosanna? 0, 1. Okay? So, again, domain, range, horizontal asymptote, and y-intercept, same as we saw above. Okay? However, it's just decay going in the decreasing direction. Okay? As you read it left to right. Now, if we look at 1/2 x plus 3, what would happen? Bless you. Nolan? Excellent. Good. It will go up 3 because the 3 is on the outside. Okay? So if we look at our original table of values, what values now will change? X or Y? The Y would increase to 3. So we would have -2 what? 7. Good. -1. 5. Mm-hmm. Or Y would add 3. Okay. So your Y would add 3. Okay. So now, out of domain, range, horizontal asymptote, and y-intercept, okay, what stays the same? Nolan? Just the domain. Okay. Just the domain. Okay. What would the range be? Esteban? Good. Parentheses 3 to infinity. What is my horizontal asymptote? Yep. Y equals 3. What is my y-intercept? Do you know? 0, 4 would be your y-intercept. And to also check, if we plugged in 0 for x, what's 1/2 to the 0? 1 plus 3 is 4, what we got. Okay, so moving up 3 changed your range, your horizontal asymptote, and your y-intercept. Those 3 changed. Okay, so you guys are gonna try a few. Okay, 1, 2, and 4. Okay, I want you to try those on your own. 1, 2, and 4. Go ahead. All right. If we look at 1 and 2, okay, very basic, very similar to what you just saw. Okay. For number 1, obviously it's a growth. Okay, 3 to the x. You're increasing. Your horizontal asymptote is 0. Your y-intercept is still 0, 1 because there's no movement. Domain and range still the same. How many of you did get that for number 1? Fabulous. Good. Number 2, we moved up 2, so therefore our range and horizontal asymptote definitely changed 2 to infinity. Horizontal asymptote is y equals 2 because you moved up 2. And our y-intercept is now 0, 3. Okay, how many of you guys got that one? Great. All right, number 4, I didn't do out right now because I want to go through with you guys. What transformations are happening? Liam, go ahead. Okay. Right 1, down 4. So if we look at just our y-intercept right here, 0, 1. If I moved right 1, where am I? Well, if I'm going from 0, 1, right? If I move to the right, I'm at 1, 1 right now. Then I have to move down 4. 1, 2, 3, 4. Okay. All right. Then 1, 3. Okay, you're at 2. 3, 1, 2, 3, 4. Okay. And then you would keep going, right? What is our new horizontal asymptote? And I'll plot more points. What is our new horizontal asymptote? Danielle? Y equals -4. Okay. Okay. All right. So what is our domain? Lila, what's our domain? -infinity to infinity. Let's see. Rosanna, what's our range? Good. -4 to infinity. Okay. Did anyone find out the exact y-intercept? Louise? Excellent. -11 over 3. Because if you do 3 to the 0, was it -1? Then -4. You have 3 to the negative first, -4. So you have 1/3. Now, you need a common denominator before you subtract, which would be 3. -12/3, which gives you 0, -11/3. Okay? So, this moves over. Okay, that's what your graph should look like, or something similar to it. All right. Now, I left number 3 as is. Some of you probably already did already. Okay. What's happening in number 3? What's one thing that you can name? Caitlin. Reflection. Good. What else? Nolan. Vertical stretch by 2. So, we have our own values here. Original parent function is still 3 to the x. That's still your parent function. We're going to take our original values and do what to it? How can we show the reflection and vertical stretch? What do we have to do? Sawyer? Multiply what? Multiply all the y values by -2. Okay. So We have new points here. -2/9, 2/3, -2, -6, -18. All right, so 0, -2. 1, -6. 18 somewhere down there. Okay, so here's our new graph. What stays the same? What's one thing? Brayden? Domain, good. What else stays the same? Louise? Which is y = 0, okay. What's different? Danielle? Which would be what? -infinity to 0. So when you have a reflection, your range will change, okay? -infinity to your asymptote, okay? So reflection changes your range. It also changes what is your y-intercept. CC? Yep. 0, -2. Okay, good, excellent. So that is graphing. The only thing that's different is just the shape of the graph. We know everything else, right? Pretty basic. So you guys are going to try some practice. Okay, for the 4 graphs, I know some of you are still working on them. A lot of you are done. So if you look at number 5, okay, this is our parent function. What is it, growth or decay? Decay. Okay, what is our domain? Emma, what's our domain? -infinity to infinity. Our range, Genevieve. 0 to infinity. Esteban, horizontal asymptote. Excellent. Jackson, y-intercept. Good. Okay. So for number 5, this is what you should have. Okay. Now if we look at number 6, Taylor, what's our domain? Excellent. Nolan, what's our range? Good. Cyan, what's our horizontal asymptote? Y = 2. Good. Liam, what's our y-intercept?
Y-intercept is 0, 3.
Excellent. Good. Okay. So 5 and 6. Good. Yep.
When I'm doing the table,
Mhm.
for 1, 2, like I got like 1, comma like 7/3 or something, and then 2, comma 19/9. But shouldn't that be like below the 1?
Okay. So for 1/3 plus 2, right? You would have 1/3 plus 6/3, which would give you 7/3, which is 2 1/3. Okay. Then you would do the same thing for the 9th. So no matter what, those 2 points, okay, they're not going to be as accurate on your graph, but they will always fall literally staggered above that line. Okay? All right? So if we look at number 7, okay, who did I? Sabrine, do you have our domain for number 7? Good. Addison, our range. Good. Horizontal asymptote, Lila. Y = 0. Jack, y-intercept. Awesome. Good. What transformations were happening in number 7? Louise. Okay. Is one of them. Caitlin, what's the other? Good. Awesome. Good. All right. Number 8. Sawyer, what's our domain? Awesome. Danielle, range? -4 to infinity. And just by looking at it, Paris, number 8, what's our horizontal asymptote then?
-4.
Perfect. Y equals -4. Assad, what's our y-intercept? Yep. 0, -1. Good. How many of you did get all 4 of those correct? Perfect. Okay. So I will be giving you your practice. Okay. It's going to be in the blue packet. Pages 1 through 3 is just the 5.5 practice. Okay.